And BW Merlin, welcome to the club. Thank you. So let's see here. When last we met, we were switching over from, we had been doing select ID. We were doing select ID from users where last access date is greater than July the 1st. And so what we said was we were going to scan the entire table, and then we were going to write down just ID and last access date, because those were the only two columns that we needed in order to sort this data. Now things are different. When I switch over and I do select star, things are going to change. Now I'm going to keep the original query so that we can show them back and forth between the two. But up here now, I'm going to do just select star. So before I do it, I want to remind you that the cost of this query, if I look over here on the estimated subtree cost, was 12 query bucks. 12 punctuation matters. What punctuation are you talking about? Punctuation matters. I agree. I'm also an Oxford comma fan, just for the record. Table seek after where? So what table seek to what, though? What are you going to seek to? So this is where it gets tricky. What's your execution plan going to change to when I change it over to select star? Is anything about this plan going to change? So let's go see. Let's go run it. If I look at this execution plan, I look over at the plan looks identical. Somebody says missing comma before the alias. I don't know what you mean. There's no alias here. I'm not sure what you're talking about. So I require all the data now. The difference is if I look at the arrows moving around here, and yes, Red Baron, bingo. I am not, when I run these little mini programs, remember every one of them is self-contained and independent. The first microservice here that's going to run is my clustered index scan. So now the output of the clustered index scan is way larger. We're returning all of the columns instead of just ID and last access date. So now this arrow you can think of as 150,000 rows that have select star off of it. Oh, Nibble Ninja! Yes, Nibble Ninja, you are absolutely right. There are also more reads. Nibble Ninja was really paying attention, because now, before I could just skip these off-row columns, the things with giant letters to grandma that someone wrote in there about me, now I have to go get those. Now I have to bring those in too, and I have to write them down. So we're talking about higher logical reads too. Nibble Ninja, that is just absolutely fantastic, because hardly anybody ever gets that. So you're just really a cut above there. So now, and you don't see that on the plan, it effectively looks the same, because really it's all bundled into the clustered index scan work, but it's going to be more reads for that clustered index scan. Now, the sort is bigger too, because what this sort is doing is writing down frickin' everything. When our users ask for select star, we got to write all of the data down. We don't just write down ID and last access date. Now, some of you who are developers may be thinking, why don't I make 2 trips? Why don't I send my friends to the closet once to go get all the IDs and last access dates? Then they can sort them all. Then they can go back to the closet to get the select star. That's not how SQL Server works. SQL Server wants to get you in and out of the closet as quickly as it possibly can, because other people need to get into the closet and read these rows too. There's more people who want to grab locks on these, and I can't afford to hold locks while I work. I need to get you in and out as quickly as possible. So that's the reason why SQL Server does something that you may not agree with at first. So now, when he goes through and does this sorting is way more expensive. On my humble laptop, the select took 32 seconds longer than yours. You might be using the full Stack Overflow database. I'm only using the 2010 version here, which is only like 10 gigs. If you're using just the 10 gig version and it took 32 seconds, Solomon DBA says, how do I follow you? Get behind me. So now, the sort is spectacularly more work, is way more work. How much more work? The easiest way to see this for starters is to run both of these queries back to back. I'm going to highlight both of them and run them, execute. Then the cost over as I estimate stuff, if I hover my mouse over here, that really doesn't tell the full story. If I hover my mouse over the first one, it says 12 query bucks, 12.58 query bucks. The cost of the second one when I'm doing select star, buckle up, 876 query bucks. It's up by like 30x. Now, Sakir says, I've always heard select star is bad. This is one of the reasons why you hear select star is bad, is that it's so much work to do the select star. But it's not more reads in this case. It's a tiny amount more reads. It's more CPU work to select all of this stuff. So the place that we find that is by looking over here, the first query when we only got the ID, so ID is 157 milliseconds. Then when we did the select star, it was a full second. So select star CPU time was a full second. So that's insane. It's like 5, 6, 7x more. It's ginormously higher. So what you'll hear when you talk to database administrators, you'll hear, don't select star because you bring back more data than you need. I'm actually okay with select star. Because check this out. If I go back and do select star, but I don't highlight the order by, if I just do select star, it's hardly any work at all. It's actually not that big of a deal. We're just doing the clustered index scan. There's no CPU work. We throw a whole lot of people into the closet. We make them bring back all kinds of rows. This isn't really that bad. If you need 150,000 rows and you need all of the columns, the cost on this little fella is only like 5.8 query bucks. But when you put in the order by, this is where the query cost is. So here we went from 5 query bucks to 875 query bucks. I don't actually have a problem with people doing select star. I have a problem with people who do joins, group by, order by, any kind of post-processing. The more columns that you add, the more screwed you are. And of course, out in the real world, you're not doing select star from table with no where clause. You're joining 42 different tables together, and you're doing group by and order by and having and all kinds of stuff, CTEs and temp tables. So I'll talk about how select star isn't really the enemy, but it's everything that we do with the data. For example, here in this, that first microservice, that first application, it's easy for him to just pull out all of this data, but it's everybody upstream that pays the price. I like to say that SQL Server is the world's second most expensive place to sort data, with Oracle being number 1. SQL Server Enterprise Edition is $7,000 US per core, which sounds like a lot, and it is. But $7,000 a core is nothing compared to Oracle, which is $47,000 a core for their Enterprise Edition. That is the world's most expensive place in order to sort data. Now, Most Wanted says, what happens when you order by rand? Does it get even worse? Not really, because effectively the work is just sorting every time. It doesn't matter what columns you're sorting by. You're still kind of essentially screwed there. You're having to rebuild that work every time. So speaking of which, what happens when we run this query twice? If I just sorted this data, if, for example, if I go in and I say at the end of my query, go 5, meaning go do this 5 times or 50 times, think about what your execution plan should look like now. What you would probably do is you would send your friends into the closet, have them go pull out the rows, then have them all do all this ordering, then have them save it. Have them keep this around. Maybe they keep it for 30 seconds, maybe they keep it for 2 minutes, but just keep this piece of paper for a while. It's not what SQL Server does. So let's see what SQL Server does. And to do it, I'm going to bring up Task Manager because this is kind of amusing to see. When you bring up Task Manager, you want to first just let it kind of stabilize there so that it'll drop back down to 0. And then while it runs, I'm going to go run this select star 50 times. Wapow, there goes my CPU. Because SQL Server caches these, SQL Server does not cache these. Is it smart enough to remember that you did it one time and go back? Nope. Doesn't matter if 10 people are running the same query at the same time. They each get their friends to all go into the office supply closet. They all scan the table. They all do the sorting. It doesn't matter if the query was just run. It doesn't matter if no inserts, updates, or deletes have happened. Thank you for following. Thank you for following. Thank you for following. Okay, easy now. Easy now. You don't get multiple points. There's no multiple credit here. Just follow and pay attention. Even if no one's inserted a row, even if no one's changed a row, even if the database is marked as read only, even if no one has logged in, even if you're an availability second group or availability secondary replica or a log shipped replica, SQL Server every single time reads all of the rows and does all of the sorting. So my CPU now is just going through the roof as SQL Server rebuilds this over and over again every time. So in terms of what I tell developers, I know when I was a developer, I used to think, well, I just ran the query recently. It should still be in cache, right? This is not. So when you're building an application, as early as you practically can, put in a caching layer. Redis, Memcache, I don't care who you use, put in some kind of caching layer because the fastest query is the one you never make. The fastest query is the one you never make means if SQL Server doesn't have to put together an execution plan, go send his friends to the supply closet, go sort all those rows, you get your answer way faster. Brent is a developer shudder. Oh, my years of classic VBScript ASP. So this sucks. We got to do something better than this. We're not going to be able to run this query over and over again, and that is where indexes come in. So let's go make our first index. Let's say if we're constantly querying this, and we're not going to do the select star anymore because that select star is terrible. We've taught our developers, hey, stop doing that. Instead, just get the columns that you need. And they're like, okay, we could just get by with ID. In reality, no one's ever said that ever. We'll talk more about that in a while. Hung easy. Welcome to the club. So I want to create an index. I'm going to say create index. I'm not going to call it IX anymore. I used to put in IX, and then gradually over time I realized there's no point to that. I don't need to say that it's an index, and now these days I think of these as Roman indexes. Anytime I see IX at the beginning of that. So what I'm going to say is instead last access date ID on DBO users last access date ID. So I'm going to go create this index, and I'm going to visualize for you what this index looks like. When you're building indexes, you want to visualize them to see the kinds of things that they contain. And I talk about how to do this in my fundamentals of index tuning classes. I'm just going to write the query here to show it. Select last access date ID from DBO users, order by last access date ID. So this is literally what the AK pages look like inside your database. For those of you who printed out the AK pages that were in your homework, these are the black pieces of paper. The first thing that you're going to notice is that there's a hell of a lot less data because I only have to store last access date and ID. I can cram way more rows onto these 8K pieces of paper. I can cram way more rows onto here because I'm storing less data about them. I can fit like 5 times more rows on each one of these pages than I can each one of these pages. The next thing that you're going to notice is that I have 2 copies of the table. Every time I do an insert, I have to update 2 pages. Every time I do a delete, I have to update these 2 questions. or update these two rows. In terms of that question's totally good, but it's beyond what I cover in this session. I do cover that in fundamentals of index tuning. And if you stay tuned till the end of the broadcast, I'm actually going to give you a coupon code to get that course for free, just to get your training going. So now I have 2 copies of the table in order that I have to keep in sync every time people do an insert, update, or delete. This is actually extra space on disk, but now it pays off. It sucks for inserts, updates, and deletes, but it sucks for inserts, updates, and deletes. It's great for selects when the query beautifully matches the index that we have, and in this case, it does. Let's go execute the query now and go see how our execution plan looks. Now before, in order to execute this query, I used to have a much more complicated plan. I used to start with a table scan, then I had to write a bunch of stuff down, and I had to sort it all. Now, SQL Server has a different operation here. It says I'm going to seek. It didn't say scan. It said seek. I'm going to dive bomb directly into just a few rows. I'm going to dive bomb into one spot of the table and then start reading from there. So, remember how earlier when we had the table scan, when we were just scanning the whole table looking for everybody, if Gringo says, does order matter in an index? Yeah, you're about to see why. Because this index starts with last access date, if I hover my mouse over that index seek, now instead of a predicate, it says seek predicate. We're going to jump directly to one part of the table and read out just the rows that matter. Remember before how we had to read like 300,000 rows when we were reading the whole table? Now we don't. Now we read only the rows that we need in order to accomplish the query. Now everybody kind of knows that indexes reduce the number of reads that you do. Remember before we were doing about 7,000 reads in order to scan this whole table. But now if I go in and look, now we're doing only 335 logical reads. Oh, that's absolutely magical. Now, as a follow-up, Red Barrett says, so if the index columns were reversed, would that where clause not be so efficient? Let's go see. Let's go do it. So to find out, I'm going to run a stored procedure that I'm sure you run every day. Drop indexes. Drop indexes does exactly what you think it does. It's an open source stored procedure I wrote that drops your non-clustered indexes. So the index I just created is vaporized. I do leave behind the clustered index of the table. So now let's go create, because I want to say it was Red Barrett says if the order was reversed, let's go create them the other way. ID last access date on DBO users ID last access date. Now, if ID goes first, can SQL Server seek directly into one last access date? No. If I go run that query, go hit execute, and I look at the plan, SQL Server can't seek in anymore. Now it has to scan the whole index, and it has to read a whole lot more rows. It has to read all 300,000 rows in the table. The first column of the index needs to be exactly what you're searching for. And as you start searching for multiple things, we talk about that in the fundamentals of index tuning classes. How do you figure out which column goes first, for example, especially when you're dealing with a wide variety of data? So I'm going to go back and drop that one, drop that index, and then let's go back to our originally scheduled index. We'll go back to our index on last access date. Then we'll go back and run our query again. So now we seek directly in on the black pages. Let's zoom in. Now this query, Nibble Ninja says, when would you want an index on the clustering key? I don't talk about that in here, but I talk about it in mastering index tuning. It's a great question. It's just a really hard one to cover in the time that we have. So now I'm down to just this index seek, and everybody kind of knows that an index seek on the right set of indexes will reduce the amount of reads that we do. But that's not the only part that's cool. What else is cool? So Havit, let's not try to answer each other's questions inside here, just because it's going to be kind of tough on the chat. So if you want to answer someone else's question, kind of hold off for now, or consider getting your own channel. Just maybe. And seriously, too, as a side note, I am a huge fan of community-based training. Like, I think that all of us should be out here trying to teach each other as much as we possibly can. For that, there's never been a better time to get in and start doing your own blog, do your own Twitch channel, do your own presentations, etc. Especially because it's not like we're getting out and doing user group sessions anytime soon. Now is your chance to become, famous, quote unquote, and it leads to better job offers, leads you to be able to run your own consulting company, have webcasts from the comfort of your own home on Saturdays. You know what they say, why work 40 hours a week for someone else when you can work 80 hours a week for yourself? Dave says, where are you, Brent? I am in downtown San Diego, California. The view isn't quite as magical because it's a little bit of a overcast day here, but hey, it's not like I can complain about too much there. All right, so back to the show. So in here I said the index helps us do less reads, but that's not the only part of the story. Indexes help us do less CPU work. Because if we don't have to sort this whole thing every time, we do way less CPU. Now it's harder to see that in here because I have 0 milliseconds right now. So let's go back to showing you the one with the clustered index. Let's go run both of these queries side by side. And for the top one, I'm going to use an index hint with index equals 1. What this means is go use the clustered index of the table. This is always index ID number 1 when you have a clustered index. So for the first one, I'm telling SQL Server, look, I know there are better options, but I want you to use this option. It's like, okay. Let's run both of these back to back, hit execute. And then let's go look at the execution plans. The top one, when I do a clustered index scan, the top one involves 172 milliseconds worth of CPU time. Now remember, I'm purposely using small databases here to keep the demos quick. The bottom one, when I let SQL Server choose and it chooses the non-clustered index, 0. I don't know about you, but I will take 0 CPU time all day, every day. This is the much faster way to go. This is why we get so excited about having great indexes to support our queries. They reduce reads, they reduce CPU time, and if a query is going to be run over and over again, it probably makes sense to have this. This case, this index is called a covering index. Now what that means is this index perfectly covers the needs of the query. Now, BW Merlin asks, what about elapsed time? If you joined in earlier, you might have remembered that I said I don't use time very often in order to gauge queries because it's so unpredictable and unrepeatable. It'll change all the time, even on the same VM with no other workload going. I don't use clock time as a measure for success for queries. If you do want to use clock time as a measure, what you have to do is run A/B tests. So you run the queries back to back, A, B, A, B, A, B, A, B, A, B, A, B, and then you throw out like the min and max, and you take averages or medians across all of the rest. And that'll give you a more reproducible number about what time looks like. Kind of a pain in the rear, though. Okay. So we said this is a covering index, meaning it perfectly covers this particular query. Covering doesn't mean it's a special kind of index you create. It just means that you handcraft and analyze a particular query and make an index that absolutely matches it. Huckleberry salmon, I like that. Wonder if that refers to the fish or the color. They're both good answers, but just wonder if they refer to the fish or the color. But in a perfect covering index will allow us, in a perfect world, to seek directly to the data that we want. If I run that query again, now that we have a perfectly covering index for it, and I look at the execution plan, if I look in here, it's an index seek with nothing else on the plan. And at first you think, oh, it's amazing, it's beautiful, it's fantastic. Fish. Oh, I love it even more. I love salmon. We literally had salmon last night. I love salmon. So you might think that an index seek is like as good as it gets, but look a little closer. If I hover my mouse over that index seek, look at the number of rows I read. When you and I hear the term seek, we automatically think, oh, it's lightweight and fast. But here, I'm doing a seek that reads out half of the table. It reads out half of the rows in the table. The term seek only means that you jump into the table at a point and start reading. It doesn't mean you stop there. And to show that as an example, will you share the session? No, I keep everything that I do, I keep it tightly sealed under my mattress. No one will ever be able to see it. You can tell I'm lying, right? It's already given away for free on my blog. If you go to brentozar.com/go/engine. So if you go brentozar.com/go/engine, you get slide PDFs, the demo scripts, all kinds of stuff. So if I add ID as a predicate, will it still use a non-clustered index? I'm going to hold that and I'm going to save it for later because I address that exact thing. It's a really good question, but I'll hit it in later. So here we've got a seek that jumps into one specific point, but it just keeps reading. What if I change the dates? I'm going to change these dates to something a little bit earlier, the 1st of 1800. Now, pro tip, Stack Overflow was not around in the days of covered wagons, but yet you still see index seek here. And if I hover my mouse over this, look at the number of rows read. It's the same as the number of rows in the entire table. The term seek only means I'm going to jump into a point. It could be literally the first row in the table. Don't hear the term seek and immediately think that the query is fast, because it could still be inappropriately slow. Just as you can also see the term scan, and that doesn't mean it's slow. It could be fast. For example, watch this. Select top 10 star from DBO users, and I'm not going to put a where clause on it at all. Set statistics IO on so that we can measure how many page reads that it does. Now imagine that you were going to send your friends into the office supply closet and you were going to go tell them, hey, go get me the first 10 rows that you find. I don't even care which ones they are. Just go get me 10 rows out of there and let's call it quits. Your friend wouldn't read the whole table. Your friend would just go in there, grab a sheet of paper, and start reading this stuff off. That's exactly what this query did. He only read 5 8K pieces of paper. Thank you for following, squirrel noises. I don't know what squirrel noises make, but now I'm intrigued. So he only read 5 8K pieces of paper. That's freaking fantastic. And if I look at the execution plan for that, go rerun it again and get the plan. The execution plan is technically a clustered index scan, but look how many rows he read. You're not going to get any better than that. This is a perfect execution plan for this query. It's fantastic. It won't get any better than that. And in fact, if you add any kind of indexes that you want, you're still not going to get a better execution plan than that. The moral of the story here is that I don't want you to think that seek is fast, and I don't want you to think that scan is slow. This is one of those important things to take away with, because I don't want people walking away from this session and thinking, Sukhvir says, do the top 10 always read the clustered index's first page or whatever page happens to be in cache? Oh, that's a great question, and I don't cover it inside here, but I'm going to give you the terms to go Google for. So go search for SQL Server Advanced Merry-Go-Round Scans. So if you search in books online for merry-go-round scans, it talks about how those kinds of things get executed. It's pretty neat. It's only an enterprise edition. It's kind of fun to read through about. Okay, so in this case, that query is perfectly covered by this index. The index has everything that I need in order to accomplish this query. Let's go back to 2014-07-01, and then let's run the query again, but I'm going to change the query. I'm going to say, go get me age, display, or display name, ID, and age. Get me all three of those columns. Now, those two columns are not in this index. SQL Server has to make a choice, and there are two ways that he can accomplish this query. We're going to take our next bio break, and during this 5-minute break, I want you to think about the two different ways that SQL Server would execute this query and when it makes sense to use one of the methods as opposed to the other. So we'll take a 5-minute break here while you think about that, and I will be right back.